Good afternoon, good morning, good afternoon, and good evening, depending on your time zone. Once again, this is Specialized Engineering Channel. You are welcome to this channel this very day. We are going to start Series 1 of our discussion as planned earlier. Today, we want to start with failure analysis. And failure analysis has to do a lot with metallography. Remember last week I told you that testing is divided into two parts. The first, destructive, the second, non-destructive. And we have many of them that are called destructive testing. We have many tests that are called non-destructive. So we are going to take them one after the other. Today we are going to pick on metallography. Why metallography? Metallography is one of the most important or most crucial tests that must be carried out to ascertain certain qualities of components in engineering before you can make good use of them. Also, there's what we call heat treatment. It's done on metals to make them fit for the particular use. For instance, if you want to use a particular instrument or metal for shaft, you have to take care of after machining, you have to take care of the surface because it's going to be passing through some, the surface needed to be hardened so that it will be able to resist some level of wear and tear. And also a shaft is passing through not only wear and tear, it's also passing through what we call torsional force. This will be discussed later. But however, we want to heat treat this surface, we call it case hardening. You heat treat the surface so that the level of wear and tear will be minimized. So in that case, you will be able to achieve this through heat treatment. And when you have heat treated, you need to test to know the level, the depth of that heat treatment you have carried out, if it will be enough or it will be good enough for the purpose for which you are doing it. And the best way, one of the best way to test that out is metallography. So we are going to start with metallography metallography itself has 7 sections or 7 processes. And we're going to take them one after the other, series by series, and deal with them crucially. Metallography starts with cutting or sampling or sectioning. The 3 are the same. When you say cutting, it's sampling. When you say sampling, it's called sectioning as well. So they are the same. So when you hear in metallography, cutting or sectioning or sampling, it is all the same. So today we want to look at the process of cutting. Briefly, cutting in metallography is done mainly through abrasive cutting disc. Abrasive cutting disc has different type, but we're not going to, because of our time, we will not discuss that here today. But while cutting, there are important things you must take note of. The sample, the defective sample, you must take care of, cut it in such a way that the defected part is cut, cross-section of it is cut alongside with good part. So that during micro examination, what I mean by micro examination, under the microscope, when you are viewing it, you'll be able to see the difference between the faulty part and the good part. You'll be able to correlate. You'll be able to, you'll be able to, differentiate and correlate them together, and you will now be able to fathom out what may have or must have gone wrong. Those are the things we must take note of. Then when cutting with some people cut with flame, too bad. It's not the best. Of course, it will not be good for metallography. And the sample is altered when you apply heat to a sample, to a metal. The certain things are altered. Maybe we'll discuss that later. So to avoid that alteration, you cut with abrasive cutting wheel. And why cutting with abrasive cutting wheel? We make sure you introduce a coolant. Coolant are chemical objects that are mixed together that are corrosion resistant liquid that will help the sample not to corrode, and not only that, it will not allow excessive heat to alter the surface of the sample. Then 3, also the coolant is helping the cutting disc not to receive or retain excessive heat, thereby failing or breaking during the process of cutting. So it has multiple advantages. So while cutting, I have told you that you cut the defective part alongside the non-defective part so that you can compare and contrast. So in sectioning, all of these things that I mentioned must be observed. And also, you must be conscious of excessive heat on the sample you are cutting. Do not use flame. Then do not use, if you use a hacksaw, the surface will not be regular. You will have to grind for a long time, and you may not even get a level surface. And once the surface is not level under the microscope, it will be giving you different level of, it will not be able to focus well. So it will be giving you different elevations, and your interpretation will be difficult. So that's why you need a cutting disc that will cut it smoothly as possible, and at the same time without introducing heat. So when cutting, the sample should be between the size of 1 inch to 1.5 inch. That is to say, you can cut your sample to be 1 inch or 1.5 inch, so that it will not endanger your finger when you are grinding or when you are polishing. The polishing does not endanger the hand as much as grinding. If it's too small and your finger tip touches the grinding paper, it could chop it off, and it's very painful. So that's why the sample must be very. So you make sure that you measure at least 1 inch or 1.5 inch. Some persons may be able to handle 2 inches. It is not, but it must not be excessively, long, so that under the microscope too, you'll be able to have enough clearance for it. So that is for cutting. And when we are talking about metallography or failure analysis, these following are very important. 1, it measures case depth. That's what I told you earlier. Tells you the after heat treatment, it can reveal the thickness of the brittle aspect or the hardened aspect. Where you have heat treated, it will tell you, you'll be able to see the depth during etching and during microscopic view or microscopic examination. Not only that, it measures case depth that are too shallow, can account for parts failing to meet the service requirements. You'll be able to know whether this will be able to meet your service requirement. Metallography will reveal that. Not only that, observe the carburized layer. You'll see that metallography often reveal site for cracks initiation. Where cracks can be is initiated, you can notice that. Also, incoherent or incorrect transformation of microstructures that gives general evidence of inadequate heat treatment. When the heat treatment is inadequate, you will see some incoherent transformation. So by the time we will go into interpretation, we will see all of those things. So also, we can observe crack under the microscope and their relationship to grain structures. This is a wide topic which we will deal with later. So without microstructural analysis, surface crack can be erroneously interpreted. So, but with microscopic examination, you'll be able to, avert such errors. So these are the things, advantages, and the things we benefit from it. So now I want us to see the steps. We have just dealt with cutting or sectioning or sampling in metallography. And we have other 6 steps or processes that we'll be looking at much later. Metallography processes involve cutting, it involves mounting, it involves grinding, and it involves polishing, etching, and printing before you go finally to interpretation and application. So these are the processes that we shall be looking one after the other. I want you to hit the notification button, share this, comment and share, and whatsoever question you have, let me know about it in the comment section. Your questions, your doubts, let us discuss it over as colleagues and as engineers on the field. So these are the things we shall be looking at for now, for the few weeks ahead of us. So please share and comment so that we can grow together. Bye for now.